Hello, in this video I'm going to take you through some flowchart symbols and solutions which are implemented using flowcharts. First and foremost, you have already come across a number of flowchart symbols and I've included them here in just this form of revision. The first symbol is the start or the end. We commonly refer to it as the terminator. This symbol is used at the beginning and at the end of the algorithm. So if you are generating a flowchart, to mark the start of the flowchart, you use the oval shape with a start inside of it. Sometimes it's a rectangle with oval sides. It's acceptable that way. Then if you are taking an input or providing an output in your algorithm, in your program, let's say a program says, please enter a value, the input and output will be displayed inside a parallelogram. This parallelogram kind of represents a print, an output, a read, or an input, as already said. So this is the symbol that you use to indicate the input or the output of a value into the program or out of the program. Then the rectangle represents a process, which can be a calculation or any kind of processing step. We also have the diamond shape. The diamond shape represents a decision making, which means inside this diamond shape, we must have a question. A question that resolves into a yes or a no. That is the only kind of question which is accepted. So it's pretty much a condition. Here it's referred to as a condition. Then we have an arrow lastly. The arrow shows the flow. The arrow shows the flow. So your line with an arrow indicates where the instructions are going. So if you start here and you go to input, you will have an arrow pointing towards input, something like that. Let's take this and use it in an actual program, a very simple program. The purpose of this program is to ask the user to enter their name. Once we get the name, we want to output the message, hello, John, for example. So if the user says, my name is John, then we are going to say, hello, John. As already mentioned, flowcharts always start with an oval shape. This is the terminator, the start or end. Then from start, we go to this parallelogram where we get an input of name. So input is the command, name is the variable which is holding whatever the user inputs. So if the user inputs Joe, it means we are now storing the value Joe inside this variable called name. After that, we have our arrow showing the flow. We output the message, hello, Joe. Name there is representing Joe. So we output, hello, Joe. Then our program ends. We end it with a terminator or a stop. So that's a simple program right there. Let's look at another program that uses a decision. We want to ask the user to give us their age, and once they give us their age, we are going to output a message. If you are 18 years and above, we are going to output the message which says you are an adult. If you are less than 18, we are going to output a message which says you are young. So we are going to make a decision here. Which word do we output? That's a decision that we have to make there. So let's look at our program. We start it as always with our start or a terminator symbol. We want to get input of age. We want the user to give us their age, so we use a parallelogram, and the age is going to be stored in a variable called age. Once we get the age, we need to make a decision. We say, is age greater than or equal to 18? If the answer is yes, we go this way. We output adult. Please take note, the output symbol is a parallelogram again, just like the input symbol. If the age is less than 18, we output young. Then our program goes to stop. So if your age is greater than 18, your program takes this path and it stops. It means this path is not going to be executed. If your age is less than 18, your program takes this path and stops here. It's never going to go that way. All right, so that's the use of decision. Let's look at another one. All right, so this program adds to the previous one by including process. What this program is doing is we are getting 2 marks from the user. So the program starts, we ask the user to input mark 1 followed by mark 2. The user gives us their marks here. After getting the marks, we need to do a calculation. This calculation is an example of a process. That is the reason why we are using a rectangle. So we say the average is equal to mark 1 plus mark 2 divided by 2, the normal average formula. If the average is greater than 50, that is if the pass mark is at 50, if the average is greater than 50, we are going to output the message pass. Then the program goes on to end. So it will be like this, output pass, then the program ends. If average is less than 50, we go to output fail, and the program follows this path, and we go to stop. So that is the use of process, and these are very simple programs that I'm using, and I'm going to share some questions for you to try a little bit more challenging programs. All right, then we have this maze of a problem here. Let's see what is going on. We are asking the user to give us a number. If the number is bigger than 0, we are going to output the message positive. If the number is less than 0, we output it's negative. If it's neither positive nor negative, we are going to output 0. So how do we do this? We start, we get our number. Please take note of the symbols which are being used, the shapes which we are using. Correct shapes. Then we get to the decision and we say, is number greater than 0? We need only 2 answers. We are not going to have 3 answers. So yes, if the number is greater than 0, we output positive and the program stops. If the answer was no, the number is not greater than 0, we ask the question again, is the number less than 0? If the answer is yes, any number that is less than 0 is negative. So we take this part, we output negative, and the program goes to stop. If the number was not positive and was not negative, then the only other option left is that the number is 0. We don't have to ask the question again. We now just say the number is 0. So it's an output which is going to say 0. So we say 0 and we go to the end. This is how we handle flowcharts. You have to think through your algorithm before you start making the flowchart. The flowchart's purpose is to visually represent a solution. So you have to build your problem-solving skills. Once you have solved the problem, you can visually represent it using a flowchart. Thank you. Here we have question number 5, and question number 5 is a little bit it's a little bit more detailed. What is happening in question number 5 is we want to ask the user, how many numbers do you need? So the user is going to give us a number n, and we are going to count from 1 to n, printing out every number from 1 to n. So if the user enters a number like 10, it means we are going to see a program representing or outputting 1, 2, 3, 4, right up to 10. That is what this program is meant to do. Let's see the logic. We start our program. We ask the user to give us n. So n can be 10 as we did here. Then we set another variable count. We set it to 1. This is initialization. This is initialization or instantiation. Sometimes some people say instantiation. I like initialization. You assign the value of 1 to the variable called count. Now, after that, you ask the question, is count less than or equal? Is count less than or equal to n? Then the answer can be yes or no. Let me just fix this arrow here. I'm going to remove this arrow. It's not meant to be there. It's a mistake. I am going to have my feedback or my looping back come back through that. All right, so just ignore this line there and use this new one. So if count is less than n, it means we still need to count towards n. So if count is 1, we are going to output 1. Then we increase count by 1. This is called incrementing. This is called incrementing. We are increasing the value of count by 1. It's a process. It's a calculation where count increases by 1. We say count equal to count plus 1. New value of count is equal to old value of count plus 1. So if count was 1, now it's 1 plus 1, which is 2. We loop back. We ask the question again, is count less than n? Remember, we said n is 10. If the answer is yes, okay, count is less than 10. It means we are going to output the new value of count. In this case, is 2. And we increase the value of count from 2 to 3 by this process. Then we go back and we keep doing this until count becomes 11. When count becomes 11, the answer is going to be no. Then we are going to say we are done printing the numbers and our program is going to end. That's flowcharts. Keep practicing. Flowcharts are not problem solving. Flowcharts are just ways of representing the solutions which we have already figured out. Bye-bye.